So I have slides, and what I'm going to talk about is effectively the history of Bitcoin and Mixnets, and maybe some discussion even of proof of work and Nakamoto, which is some interesting historical bits which are not well known. And we're also going to talk about, of course, Bitcoin privacy, focusing on the network level, so like TCP, IP, UDP. This may be a bit basic for some of you, but for some of you may be interesting. We'll show how our Nym Mixnet works. And of course, I'm here because we are in solidarity with the struggle of the people of Ukraine against the invasion of Putin, because this is, so we do hope you are victorious, and though we try to help and we do our best. So one thing we want to do in Nym is we want to produce tools that give people freedom, not just economic freedom, but freedom to access the internet without censorship, freedom to be anonymous on the internet, which is very important if you have a dictator, like Putin, trying to find you and kill you, or at least put you in prison. And this is just something we've been working on for more than a decade. So I'm very honored to be here. Kiev is a wonderful city. I've enjoyed my time. But let's get to the discussion of Bitcoin and Mixnets. So we will, at the end of this workshop, currently, just so people know, the network is a bit in alpha mode. You can test it, and I'll give you kind of a zero knowledge proof credential at the end of the workshop to test it. But it's not, you can't just download the VPN quite yet, but soon. Oh, that did not work at all. Oh, wait there. Oh, there we go. Okay. So one thing people, has anyone here used Wireshark or Kali Linux? Okay, so I was going to demo it, but I can't hook my computer straight to the screen, but if you want to see, I can show you afterwards. Most people do not know, but whenever you use Wi-Fi, your packets are just being kind of streamed across the internet, and you can just sit here and you can watch them, right? You can say, okay, this is TLS. Someone's going to the internet, so you can see the domain name. If people are not using email properly, you can get their email passwords. Very fun, and you see TCP/IP and all the parts of it. So the main lesson, and if you're not using Wi-Fi, so at a Wi-Fi at a cafe, people could just do this to you. But even if you're using like the internet connection at home, your telephone or cable company, the people that provide you internet, can see this. And then also, this is effectively public data. So for example, even if the Ukrainian, let's say, internet is not being hacked, it can still be watched. People can look at it very easily. So, Russian, what's called signals intelligence, or SIGINT, could be watching your internet, and they would be getting this even if everything is secure. So it's pretty dangerous. And the reason it's dangerous is the internet was not really built with security or privacy in mind. This is not just a Bitcoin problem. This is a problem for the entire internet. So the internet was built on what's called TCP/IP. And so you have applications like Bitcoin, but beneath every application, there's the transport, which is usually TCP/IP, and then every device gets an IP address, which looks like 254.32.26.01. If you're using IP version 6, it's much more complicated, a bunch of like sixes, zeros, and Fs, but you can still see it. And then you eventually get down to what's called the MAC address, which is the address of your physical device, which is bound to the IP address. And the MAC address kind of identifies your device or your phone or your router. For a lot of devices, it's semi-permanent, unfortunately. But this is not typically displayed over the entire internet, maybe just to your telephone provider. But this stuff gets spread over the whole internet. And this is like a simplified explanation of what happens when you use the internet. So, you want to talk to somebody, that's your number, that's their number. You say, hey, or do you have a website? And you have this web browser or whatever, and you run it all the way through, and you send that transaction over, and it eventually, and domain names like website.com or whatever get just resolved to IP addresses. This all seemed, this is how the internet works. It was designed in the 1970s. It's been working like this for a while. Some people sometimes say, well, is this all we have? No, there's one alternative called UDP, so you may encounter this acronym. Bitcoin actually uses TCP/IP, but some of the Ethereum-based protocols or Cardano and weird stuff use UDP. Torrenting and streaming uses UDP, like WebRTC or I don't know, watching movies sometimes. And effectively, TCP/IP sends a message and asks for a response, and then they send the next message, and so a little counter. UDP just says whatever. We're going to send we're going to just broadcast it out to the whole world, and we'll see who gets the message. If not, we'll just send it again. But anyways, they're interesting, and Bitcoin uses it, of course. So this is how. When I send the Bitcoin transaction, everyone's like really into Bitcoin because it's decentralized, and I agree, decentralization is a property we should support. So I want to send you some Bitcoin, so it gets attached by a miner into a block, and then that block is broadcast to every party. There's been some fixes, but still basically what Bitcoin does. And once enough miners pick it up using this peer-to-peer broadcast, the proof of work game, which we'll discuss later, is played, and it's inserted in a block, and you have to wait. I don't know how long. I mean, it's a long time. Last time I used Bitcoin, which was not that long ago, was like 30 minutes to get a transaction through. Sometimes the ordinals and stuff, it'll take hours. But what is dangerous is that you have to remember that TCP/IP, like I said earlier, is easily observable. And even though Bitcoin does, recently they're trying to upgrade their peer-to-peer broadcast to be encrypted. By default, it's not even encrypted. It's all in the plane. And they're using techniques like, I forget, what's it called? It doesn't work very well. Kind of sends it to one node and the other node sends it. Dandelion. They're still pretty weak. And so what was happening is even back in 2015, under this interesting blog post on I think Bitcoin forum, Evil Knievel said, is someone monitoring large parts of the network? And they were pinging all of the Bitcoin full nodes, and it seemed like a lot of the Bitcoin full nodes were being ran by the same actor because they would get the same kind of ping response and SSH response. And it was being ran back in 2015, 7 years ago, by Chainalysis. So Chainalysis was watching all the peer-to-peer broadcasts, even in 2015. Okay, so definitely they have much more money now. Capturing the IP addresses, and they would use the IP address to link, because an IP address can basically track you down to the neighborhood you're in. So you say, okay, this IP address is from Ukraine, this IP address is from the United States, this one's from Russia, this one's from North Korea, and they would track this down. Maybe they'd try to track it down to see if it's you. So basically, what this means is that the internet, even the internet used by Bitcoin, is fundamentally broken insofar that metadata, who is talking to who, kind of leaks at the network level. Every cryptocurrency transaction, including Zcash and Monero, expose this peer-to-peer metadata to be harvested and exploited. And so it doesn't really, you use Zcash, but it doesn't really matter because someone's going to pick up your IP address and maybe link it to you, right? So it's quite dangerous. Or let's say I like Liquid, I'm using confidential transactions and stealth addresses on Bitcoin. I can still get linked. And no existing solution can defend against statistical analysis as done by Chainalysis. So there's a few options here. And what you want to be when you use the internet, you probably want to be anonymous. You don't want necessarily people to know that I'm sending Bitcoin to someone or using Signal or, God help you, I'm in the Ukrainian army fighting Russia. I don't want Russia to know who I am or what I'm doing on the internet. So you want to be, there's a bunch of senders, there's a bunch of receivers. And what you do to make the internet anonymous is you put a bunch of what's called an anonymous overlay network on top of the internet, and your internet traffic comes through and goes into this weird network and comes out, and then someone who's watching network has to kind of guess which of these 3 to thousands of people you could be, and they don't know exactly who you're sending the message to. And this works today. So effectively what people do with VPNs there's some good VPN providers. I'm kind of like Mulvad VPN and Calyx and RiseUp. I would be very careful with most mainstream VPN providers. Most mainstream VPN providers, including like ExpressVPN or Surfshark or even private internet access, they're actually ran by data collection companies. So what they do is, that's their business model. They collect your data and they sell it. They're all ran by a data collection company called Cape Systems. And a lot of other VPNs are similar, particularly free VPNs on the internet are usually kind of traps. They gather your data and they try to hack you or sell your data. Be very careful with quote unquote free VPNs, unless it's ran by someone reputable like RiseUp. And people like Mulvad are probably okay. But the fact of the matter is, with any VPN, you really have to trust that VPN provider, because this is your internet traffic. It has internet traffic creates like a fingerprint. The packets, remember these TCP/IP packets that we're sending, they have a certain timing and volume information, and this creates like every website looks a bit differently, so they can kind of see what you're doing, and the VPN provider sees everything you're doing. So you better trust them, and I would not trust almost any VPN provider. So Tor tries to make, has anyone here used Tor? Any Tor users? Okay, Tor's pretty cool. It's free, which is nice, and it's not a sketchy VPN. So it uses, it sends you through like 3 VPNs. You go, whoop, and you get out, so you go through the first, called your guard, to the relay, and then to an exit node. And it's decentralized, it's volunteer run, so it's kind of cool. It doesn't have like a central single server that can monitor you. But the real question we don't know, Tor was designed, 20 years ago. And so back then, AI and machine learning were a lot less powerful. So again, if we're concerned about something like signals intelligence, traffic analysis, let's assume, the Russians are trying to figure out who Zelensky is talking to or who you're sending Bitcoin to. They can just watch all the traffic coming in, and they can watch all the traffic coming out. We'll illustrate that in a second. Oh, it doesn't. That they can kind of correlate that traffic. So what a mixnet does, which was first proposed by David Chaum in this actually still very readable paper called Untraceable Electronic Email Return Addresses and Digital Pseudonyms, published in 1981, so a very long time ago. He said, well, look, we can eliminate metadata by not sending the coins into a mixer, but by sending every packet into a mixer. So the packets come in, they're like mixed up, they're sent out. So the mixer just kind of waits to get enough messages, kind of shuffles them like a deck of cards. If you're a mathematician, it permutes them, and then sends them out again. And as long as the messages are encrypted, it's harder to link the input to the output messages, right? That's kind of cool. It's a few tricks, but we'll discuss. And so that's what Nym is. So Nym is a mixnet. We finally coded the mixnet concept up. And we do some things. So you can see with a VPN and with Tor, you can de-anonymize by kind of looking at the traffic patterns. With Nym, it's much harder because the patterns are, you can see here, the patterns have like a shape. Here they kind of, they all look the same when they're coming out. All the packets are made the same size. And we send fake packets in. So if you're not producing enough packets, you don't want to know when someone, when you're using the internet, we can add fake packets in. And this produces what's called unlinkability. So that means that you cannot link the sender to the receiver. And because you're always sending fake packets, you're called unobservable. If you're interested in this terminology, there's a paper by Andreas Feitzman, which kind of explains it all. From about 2000. And so the danger is, like, you can say, well, okay, sent my encrypted packet to the mixer, but then what if I flip a bit on that packet? Let's I change one of the ones to 0 and I look for that pattern coming out the mixer. Couldn't I identify you, even if the packets came out at different times? And the answer is actually, we use something called the Sphinx packet format, which you guys, anyone here use Lightning ever? Lightning? Any Lightning users? Okay. So Lightning also uses this packet format. And the Sphinx packet format is pretty cool because it makes all your packets the same size. If your packet's a bit too small, it adds a bit of data at the end. And then at each hop in the mixnet, because remember, you're sending things between different servers. Each of these dots is a server, and these are your packets. You're kind of going through one server to another, and then you go send some more packets. It chooses like a different path, right? At each hop, the Sphinx packet format effectively re-scrambles the encryption. So decrypted, the data is still there, but encrypted, it's unlinkable. You can't figure it out because there's a new zeros and ones. And we think that's quite cool. And I want to show you how to use it. If you're interested in using it, I don't know what wallets do people use in Ukraine? Can someone tell me? Does anyone, maybe everyone just uses Binance, but does anyone use like a wallet on their phone or on their desktop? Which ones do you use? Electrum? What? Okay, I haven't heard of that one. What other ones? So I use Blockstream Green, so I just use this for the example. I don't have much Bitcoin in the wallet on my phone. But so if you have a Bitcoin wallet, and this is for Blockstream Green, but most wallets have this option somewhere, you can turn your wallet on, and there's usually like a user settings, right? Somewhere like down here. It's a little, everyone does something different, but this is, and what you do is you go to your settings, and at least on Blockstream Green, you go to the network button, and you press the network button, and it says, do you want to connect with Tor? And we're like, no, we want to do something even more cool. We're going to connect with a Nym Mixnet. And then we click this connect through proxy button, and then you say, okay, what's my proxy? I don't know. There's a proxy port and a proxy host. So the host is like where you're sending your traffic. Could be a VPN. And the port is like where the traffic comes out on. That's a kind of something on your computer, let's say. And what we do is we have made a piece of software. If the community would like to maintain the software, we're kind of tired of maintaining it and be happy for someone else to maintain it. But it's called Nym Connect. You can download it there. And you download it, it just looks like this. It just says, hey, you're not protected. So if you want to get protected, you just click that big button. And it says, cool, you're halfway there. And it gives you an address. This is using a protocol called SOX5. If you use Monero, it's more or less the same thing in Monero. And it gives you a port, and you cut and paste those into Blockstream. You cut the port here and the host here, and you're using the Mixnet over whatever wallet you want. So it's kind of nice. It's not so hard. I mean, you still have this cut and pasting. You can make some mistakes, cut and pasting. So we've been running, this has been running for 2 or 3 years now. It's pretty cool. But we said, to be honest, it's kind of hard to use. Like, people don't like the cut and pasting, and every time you have a new application, you have to cut and paste again, and people forget to turn it on, and so it has these problems. So we said, okay, so we're going to make a VPN. Because how many people here use VPNs? What VPNs do people use?
What for? Or specifically?
Yeah.
Those 3 ones. Setup VPN.
But just tell me one. Do you know the name?
Setup VPN.
Setup VPN? Okay.
Self-hosted WireGuard server.
Browser.
WireGuard server is pretty cool. Yes?
Browser.
Okay. And
Private internet access.
private internet access? Okay. And you want what?
OpenVPN.
OpenVPN? Yeah, you run your own OpenVPN server? Which one?
Clear VPN.
Okay, I don't know the clear VPN. I'll look it up. But essentially, we want something that's like as secure and private as a VPN, but actually secure and private, using this cool Mixnet technology beneath it. So we're trying to make Mixnet. This is a little bit of a mess. We want to make it as easy to use as a VPN. And we looked at all the VPNs, and there's some which we think, oh, they're not so bad, but they're kind of centralized. And there's all these weird decentralized VPNs, and we couldn't get many of them to work. And then there's like onion routers or garlic routers, I2P, Loki, of course, Tor, but they have these traffic analysis attacks. And there's these like Mixnets, but these are all like some like zero knowledge network are just scams. Others have kind of inferior architectures like Hopper. Elixir from David Chaum we like, but we're worried about scaling. So it's more maybe for cryptocurrency than VPN-like usage. So we decided we're going to make a Nym VPN, which basically adds this fake traffic all the time on your internet. And so it can defeat even like really sophisticated AI-based surveillance, which would include, we hope, Russian traffic analysis. And so how it works is you just download it. on the first hop, so if people are familiar with WireGuard, it's really fast. But the Mixnet, of course, because it's doing all this packet mixing, is a bit slower. So when you use the Mixnet, you're more private or anonymous than Tor, but it's a bit slower. And you can turn the Mixnet off and on. You can use it as a normal VPN by turning the Mixnet off, and you can turn the Mixnet on, and it works. And we actually have a version of beta testing, so you can say, I want to use the Mixnet, or just click a button, I just want to use a normal VPN. You say, oh, I want to come in Sweden, come out in France, or whatever. And you can download it, and it's a little, it's in testing. And but it works on Linux, Mac, Android. Android is actually probably the most stable. So use Android. Yana can, in the back, say hello, Yana. She can show it working on Android. It's the first kind of easy to use Mixnet. And then we're going to do a bunch of cool stuff in the future, like make it hard to be censored so people in China and Iran can use it, or maybe people in occupied Ukraine can use it without being noticed. Add post-quantum crypto and make it so different apps can use different Mixnets, or you have like apps that want to run faster and apps that you're okay with being a bit more private and you can run a bit slower. And we are all gonna ask people to pay for it, but you can use it for free for alpha testing, and we'll probably let Ukrainians use it for free anyways, because everyone here has security problems most likely compared to normal people. So you can try it out. You can just go to our website and download it. You can just download it, and then we'll give you the key, the kind of secret passcode to access it later after the workshop, as I said earlier. And it's kind of the first part of a bunch of other stuff going on. If you like JavaScript, you can embed. We have a whole workshop on this on the Nym meetup about how to run a mix node. Let's say I want to run you run a Bitcoin miner, you make Bitcoin because you mine. With Nym, you mix packets, you make Nym token because you mix. And Nym is registered with with a prospectus in Switzerland. So we have a lot of cool stuff going on. We do hope to launch it maybe August. So people will be able to pay for the VPN just using Bitcoin or whatever else they want to use, Monero, whatever. And we think it'll be ready for really widespread usage by October. Trying to get there before, we're a bit worried if Trump becomes president, to be honest. We're trying to get there by end of year. This is who we're letting in, but your friends you get in first. And we don't know how much to charge. So if you have any opinion, we're looking at other VPNs. People tend to charge $5 or $6 a month. But again, I think we can do different. We can make it free for people in places like Ukraine. But I want to end with, this is me and Adam Back. So Adam Back is famous for inventing proof of work. A lot of people think he's Nakamoto, but I want to end, so that was Nym, but I want to end with a little bit of the history of Bitcoin and mixed networking. And most people don't know this history, so I kind of want to talk about it. Adam is a good friend. He supports Nym despite that he hates everything but Bitcoin. And he supports Nym because Adam is an old school cypherpunk. Cryptography like Nakamoto. And Adam was running something called a anonymous email remailer. So what anonymous remailer is, I'll explain in 1 minute. Anonymous email, so what happened is this probably everyone doesn't remember this. I was pretty young when all this happened. I was a teenager, right? So when the internet was kind of first getting going in the 90s, Scientologists, somehow someone leaked. Do people have Scientology here? Sure. Oh, you do? Okay, so I don't know if it's everywhere. I think maybe some have these weird beliefs. I hope there's no sign. Don't mean to offend anyone here, but they have some really weird beliefs. And the Scientologists, they basically put their sacred teachings got leaked on the internet, and they got very upset. And they try to say, okay, I want to find out who emailed them, and I want to make them go to jail or fine them. And the cypherpunks said, no, we want freedom of speech. So they made these things called Mixmaster, which was the first Mixnet, where you would send email to a remailer, and the email would strip out your IP address, decrypt the message, and send it to a mailing list, right? So you could mail to a mailing list without revealing your IP address, and without revealing who you are. This was in the 90s. And they used a guy called Len Sassaman, and some other folks like Lance Cottrell built the first Mixnet. so people could like spread the Scientologist beliefs and make fun of them without going to jail. And that's interesting because no one really knows who Satoshi. Know what problem he was interested in. So the thing about Bitcoin, I mean, Bitcoin's cool, but there's been a lot of digital currencies. Why did Bitcoin work? So historically, the problem with Bitcoin is you don't want a bank, a central bank, telling you how much money you owe, how much money you have. You want it to be decentralized. But somehow you historically you have a bunch of different computers. You want to decentralize something, and you want to make agreement between all these computers. You typically have like a voting process. So for example, let's say each of you in the audience is a computer. I would just choose someone randomly, like, I don't know, I could choose Yana, and then it's not random. Okay, I would choose the guy in the blue shirt, and he would be like, hi, I'm the leader, I'm gonna make the blocks. And like maybe people would vote for the leader or whatever, and then another leader is randomly selected, and it keeps going. That's traditionally how consensus algorithms work for like, so Google uses some version of this to keep Gmail running. It's working like this for 30 years. But the problem is, how is it that, what's the big problem with voting? Why do miners mine Bitcoin rather than just vote, like in proof of stake, vote with their tokens or whatever? So the reason is you don't want to identify the people in the network, right? So you need a way for people to have consensus among each other without revealing who they are. And this was solved, this is not the best illustration, but it was solved by proof of work. So proof of work was not invented for Bitcoin. Adam Back invented it to stop email spam. Because what's a problem? If you make anonymous email using an anonymous email mailer, who's the first person who's going to use it? Spammers, right? They want anonymous spam. So Adam Back said, well, what if we just make people do a bunch of hashing, and that hashing costs like a few cents or a few dollars or whatever, and then they're not going to be able to send spam through the network. But I don't want, like most spam filters just keep like a big centralized list of all the spammers, and Adam Back and the other cypherpunks were very interested in keeping everyone anonymous. So they said, yeah, we don't want they don't want a blacklist or a whitelist. We just want people to do something to prove they're human, a bit like a CAPTCHA. And that's what proof of work is. Proof of work is a capture for a computer. It basically says, okay, like you keep running this hash function over random numbers, and then you get, I mean, I don't have time to explain it all, but I hope you know. If not, I'm happy to talk about it afterwards. And after you run the hash function a bit, you get a bunch of zeros. If you get the right number of zeros, then you kind of win the puzzle and you produce the block and you get what's called the coin-based reward. Not the exchange, but the Bitcoin thing, the actual kind of free Bitcoin for winning the mining. And then every few years you have the halvening where the amount of Bitcoin goes down that you get for this coin-based reward. And so what's interesting is this is the exact same technique that Mixnets used with Adam Back to make sure they weren't spam. So we know that Nakamoto at least knew Adam Back, and he knew about Mixnets. A, because no one has figured out his email. His email didn't leak his IP address, so he was a user of Mixmaster. When he was posting to these forums, he was very good at hiding his IP address and his identity. And then he must have known a lot about them technically, because he took this technique, which comes from Mixnets, and applied it to consensus algorithms. He said, if you have a bunch of people trying to make agreement about who sent money to who, how do you actually get all the people to agree? Well, you have to have a rule, and that rule is who has the longest chain with the most weight, the most hash power. That's literally how Bitcoin works. So everyone's running these hash puzzles, and the guy that wins the hash puzzle, the miner, gets the Bitcoin, and that's the authoritative chain, and the chain with the most hash power wins. That's literally how Bitcoin works. So we know that Nakamoto knew about Mixnets. Mixnets is just not Nym, it's not just David Chaum. Again, a lot of the cypherpunks were working on it. And then the guy that was working on Mixmaster was Lynn Sassaman, who was a PhD student in Belgium under David Chaum, and Bart Purnell, who is an advisor of Nym at KU Leuven. And he ran the Mixmaster remailer and Ranseed remailer. And he was definitely like a cypherpunk, working on privacy and anonymity. He knew the guy, he was roommates or whatever, worked with Bram Cohen, who invented BitTorrent, so he knew about peer-to-peer stuff, and was interested in digital cash. So someone said that they think that Satoshi might have been Lynn Sassman. So I knew Lynn, not very well, but we were in the same social circles. I went to parties at his house sometimes. I'm not sure Lynn was Nakamoto, because Lynn would complain about Bitcoin sometimes. I didn't have enough privacy. However, there's some evidence, and when he died, he had a, somewhat like Hal Finney, he had a degenerate, it was, my guess is that Nakamoto was probably either Lynn Sassaman or Hal Finney. I kind of, or maybe a group of people, but probably Lynn probably, I actually think it's more likely to be Hal Finney, but there's a chance it's Lynn Sassaman. And the reason, and so when he died, you know, people put a tribute to him on the Bitcoin blockchain. It's cool, like ASCII art, and everyone's Bitcoin blockchain, and it's a dedicated, he's a friend, a brilliant mind, kind soul. But the thing which people said, well, you know, it's kind of interesting because when they, like, there's a lot of weird evidence about Nakamoto. Like, he was using sometimes American English, sometimes British English, and Lynn was an American studying in Belgium, so the Belgians use British English, but he also would use American English, he would use a mix. The tweeting history looks kind of similar to the Bitcoin post history, and they both disappeared at the same time. Lynn died, unfortunately, and his death was shortly after the last post of Nakamoto. So there could be some connection. Anyways, I thought that was a nice little historical story to tell, which is interesting. Again, no one really knows, and no one ever will, who Nakamoto is, but it's an interesting theory. But I do want to say that Nym and Bitcoin have a large history together. Mixnets in general have a big history. And if you're interested in talking about it, we have a website that's for like the more deep tech stuff. This is for like the kind of VPN, which you should download, Twitter, GitHub. And I'm just Harry at nymtech.net, and you can email me anytime. So that's it. I hope that was a good talk and you learned something. Happy to take questions, or I think there's another talk next, so we can